This video is brought to you by electricalexamcoach.com, offering the #1 electrical exam prep series. You can take our paid version with the Unlimited Testing Center, but you can also take our free version that is completely free without the Unlimited Testing Center. Also, if these videos have been helping you at any time, you can also go there and pay it forward to see it head on to the next generation. I am the Electrical Code Coach. Let's go ahead and get to it. Let's learn about sizing grounding electrode conductors. Everyone head to table 250.66. It's on page 116 of the 2017 and on page 123 of the 2020. Pause the video now if you need to. So the first thing we get there is we check the black bold heading and make sure that we're at the right table. And I cannot stress to you enough, the next 3 tables that we're getting ready to learn almost look identical. And if you don't read the black bold heading when you get to the table, you can be off in a heartbeat. I mean, these 3 tables look almost identical. So when we get to our table, it says 250.66, grounding electrode conductor. Great, I feel like we're in the right table. So starting on the left-hand side are going to be 2 columns, and on the right-hand side are going to be 2 columns. Let's break those down now. So on the far left-hand side, those 2 columns are the size of the ungrounded hot conductors. So whatever your service is, these are based off the size of the ungrounded hots. You're going to have a copper column and an aluminum column. Okay? So if your main conductors, your hots are made of copper, you're going to select from the copper side first. And then when you come over to the other side, you're going to select depending on the make and composition of the grounding electrode conductor itself, you're going to select from copper or aluminum. Okay, so let me be very clear and very slow right here. If our mains are made of copper, we select from the copper side. If our mains are aluminum, we select from the aluminum side. Then there's a second conductor involved. It's the actual GEC itself. And we have to cross over and make sure we select from the right column, whether copper or aluminum. Because it's very easy to go copper and then want to go straight over to copper. But whatever your real world scenario or whatever your question states, you have to be very diligent to select from the respective column here and then jump over and select from the proper column here. But we're going to do a bunch of practice questions and you'll be a pro by the end of it. Now let's all flip back 1 page. Okay? Flip back 1 page to article 250.66, okay? And we're going to do a little bit of highlighting. So we flip back 1 page, and we're going to start at the beginning of 250.66, the actual article, okay? And if you read the black bold heading, it says size of alternating current grounding electrode conductors. We're going to do some very strategic highlighting here if you're allowed to do highlighting in your state. So right underneath it at part A, I want you to highlight in the black bold heading the word rod, pipe, or plate. Rod, pipe, or plate. I want you to highlight that. Then I want you to go down to the bottom of that paragraph, and I want you to only highlight 6 AWG copper. 6 AWG copper. Highlight that. And we're done here. Now let's go to part B. And I want you to highlight the word concrete encased electrode in the black bold heading of part B. Then when you're done with that, I want you to go down to the bottom of that paragraph and highlight 4 AWG copper. Then we're going to go to part C. And I want you to highlight the word ground ring. And depending on what code book you're in, for this one we have to flip back a page or 2. Okay? We have to flip over to 250.52. I want you to flip a couple pages back to 250.52. And it's in part A, and it's part 4. And you'll see the black bold heading that says ground ring. At the bottom of that paragraph, I want you to highlight the 2 AWG. Because that's the minimum size it's allowed to be. And all of this is going to make sense here in just a moment. Because there's 2 ways that we size grounding electrode conductors. And I think this is where most people get lost. Because I know when I first got started, I didn't know the difference. And I guarantee I did it wrong every time. but there's two classifications of grounding electroconductors. You're either going to size it based off of table 250.66 if the electrode is not mentioned, or if the electrode is mentioned in your question or in your real world scenario, you're likely going to be using article 250.66, parts A, B, or C. And we're going to go through this step by step. Let's get to it. All right, now let's reiterate these ground rules for sizing grounding electrode conductors. If no electrode is mentioned, the type of electrode, so if it doesn't say ground rod or footing ground or anything like that, you're going to use table 250.66 at face value. If the electrode is mentioned, we first need to check 250.66 A, B, or C. If the electrode is not mentioned in 250.66 A, B, or C, you would go back to the table. But usually if there's an electrode mentioned, you're going to be using A, B, or C. And this is a very easy one that you can get on your test. Once you learn how to do this, you get those grounding and bonding questions, you'll be able to flow right through them. You're one step closer to being a licensed electrician. What size copper grounding electrode conductor would you select for 100 amp service with number 4 main copper service conductors? So the first thing we're going to look at our question doesn't mention the type of electrode. No, so we're going to use table 250.66 at face value. So starting on the left-hand side, we're going to select the type and size of the service conductors. So we have to go back to our question. It says copper service conductors, so we're going to start on the copper side. Then what we're going to do is go to the right side and we're going to select the right type and size of the GEC. So when we cross over to the table, we have to look back at our question and it wants a copper grounding electrode conductor. So we go from copper to copper and we make our selection. So we come across, when we tee off, we find out that we're going to select a number 8. Great job. What size copper grounding electrode conductor would you select for a 225 amp service with 3-aught main copper service conductors? So the first thing, does it mention the type of electrode? No, so we're going to use table 250.66 at face value. So starting on the left-hand side, being careful to reread our question, in this case we're going to start on the copper side. Then when we go to make our GEC selection, we're going to slide over to the right, we're going to look at our question again, and we're going to select from the copper side over here as well. And in this case, we're going to find that we would be required to have a number 4, and we would select C. Great job. What size copper grounding electrode conductor would you select for a 400 amp service with 400 kc mil main copper service conductors? First thing, does it mention our type of electrode? No, so we're going to use table 250.66 at face value. Starting on the left-hand side, selecting the type and size of our service conductors, and in this case it's copper. Then when we cross over, we're also going to be selecting from the copper side, and we're going to select a 1-aught. D. Great job. What size copper grounding electrode conductor would you select for a 400 amp service with parallel 2-aught copper main service conductors? First thing, does it mention the type of electrode? No, so we're going to use table 250.66 at face value. Normally we start on the left-hand side and then make our selection, but we're dealing with parallel conductors, and this is how we handle it. So let's head to Chapter 9, Table 8. First, we need to find the approximate area of one 2-aught conductor, just like we did with voltage drop. So we go down on the left-hand side, we're going to come over, and we're going to find the area in circular mils, just like we did for voltage drop. So each 2-aught copper service conductor, starting on the left-hand side to find our wire, then coming over 2 small columns to the circular mils and area, we're going to find that each 2-aught is 133100. And that is in circular mils. But we have 2 of those conductors, so how we handle this is we just multiply it by 2, and that's going to give us our total C mils, okay? Once we get our total C mils, we're going to head back to our original table, back to 250.66, and we're actually going to find where that conductor falls in our table. Now this is listed in C mils. If we wanted to turn it into kc mils, we would just divide by 1,000, but it's pretty easy if you just leave it in the C mils. So starting on the left-hand side, that is now the size of your service conductor. We've converted it to just one conductor. We found the area of one of the parallels, multiplied it by 2, and now we're just treating it as one large conductor. So we go down through here and we find where 266,200 C-mils falls. And in our case, it's going to fall in the 3/0, but not over 350. Because remember, this table's listed in kc-mil, so that would equal 350,000 C-mils. So it falls right there in the 3/0 to 350 section. So what we do is we go over, now we have to be careful again. Our question wanted copper and copper. So we make our selection, and we're going to select a number 2. What size copper grounding electrode conductor would you select for a 200 amp service with 2/0 main copper service conductors with a ground rod as the grounding electrode? First thing, does it mention our type of electrode? It does, so we may not be using table 250.66 at face value. Let's head back to 250.66, reading the black bold heading using our keywords. We've already done our highlighting, so we're going to find that part A states rods, pipes, or plates. Now looking down to our other highlighted mark, or at the bottom of the paragraph, we're going to find that it's not required to be larger than a number 6. Great job. What size copper grounding electrode conductor would you select for a 200 amp service with 2/0 main copper service conductors with a concrete encased electrode? First thing, does it mention our type of electrode? It does, so we may not be using table 250.66 at face value. The first thing we do is we head straight back to section 250.66, reading in the black bold headings, looking for keywords. So we've already done our highlighting, so this should be very simple. When we look at it, we're going to see that part B states concrete encased electrode. Then all we have to do is go to our second part of our highlighting, and we find out that it is not required to be any larger than a number 4. Now, this supersedes what the table says. That's why we have to be very careful, and this is where a lot of people get the answers wrong on their actual examination, because this value over here in Article 250.66 actually supersedes the table. So if the type of electrode's mentioned, go check A, B, or C and see if the answer is listed there. And we're going to select C, a number 4. What size copper grounding electrode conductor would you select for a 100 amp service with number 2 main aluminum service conductors? First thing, does it mention the type of electrode? No, so we're going to use table 250.66 at face value. Starting on the left-hand side, being very careful to check the type and size of our service conductors. In this case, it's aluminum, so we have to start here in aluminum. We go down to where our conductor falls, then we have to be careful. It wants a copper GEC, which is very common. Main service HOTS, and then use a copper grounding electrode conductor. So then we come over to the right to being sure to be in the copper column, and we're going to make our proper selection. And we select A. Copper grounding electrode conductor would you select for a 400 amp service with 500 kc-mil main aluminum service conductors? First thing, does it mention the type of electrode? No, so we're going to use table 250.66 at face value. Starting on the left-hand side with our type and size of service conductors, in this case aluminum. Then when we cross over, it's asking for a copper grounding electrode conductor. When we look through there and we tee off, we're going to find that it's not required to be larger than a number 2.